one is basically, you see the carboxylic acid, it becomes another carboxylic acid, but the difference is we add a carbon CH2 in between the benzene and the carboxylic acid. So one carbon is added between those two carbons. How are we going to accomplish that? Well, this carbon of the carboxylic benzoic acid is that carbon. So you should remember that this carboxylic acid in the product can be made from something else, right? Then you should be able to solve this question somewhat easily. That carboxylic acid should come from the nitrile, right? Nitrile can be hydrolyzed, then you get the carboxylic acid. Then in order to do that, you have a cyanide making a tag to the benzylic bromide or something. You can make it up. I mean, obviously, these reactions are something we have talked about already, so I'm not going to go the mechanisms. But the thing is that where is this one coming from? Like benzyl chloride, benzyl bromide, you've got the cyanide making SN2 reactions, and you get that. Where that's coming from, that will come from there, right? You cannot make a carboxylic acid halide. You have to reduce that first to the primary alcohol. Right? It's got to be reduced all the way to the primary alcohol. Then you can convert the alcohol to chlorine by the ethyl chloride or the PCO3. You can use the PDO3, doesn't matter. The point is, in order to make these things happen, you have to think about how you're going to manipulate each part and then what you're going to react with, how they become the starting into the next reactions. Maybe you all get there. This process can be done going backward, right? Sometimes it's easier walking backward because in order to make this, what you would need it, and then how this will be prepared to go backward, and then try to make connection to the forward, you're trying to meet in the middle. So that analysis could help you to figure out the whole process. So that is something that I want to say. I mean, this one I believe we discussed many times before. This question is probably the more difficult one that you have seen so far. The transformation is basically you start from this, you want to make that. And many of you may have forgotten what these things is. You have a carbon bearing OH, 2 oxygen there, right? That is a hemiacetal. There is an acetal, something that you probably forgot because acetal has not been very discussed. There is a hemiacetal. And how do you make an acetal? You need a carbonyl of the ketone aldehyde and you need an alcohol. So that is something that you will recognize, first of all. So first of all, if you think that, you may easily get confused by these reactions. Some of you think that, well, I'll just treat this with the sodium borohydride. Then you're going to have this ketone reduce the primary alcohol. The sodium borohydride is not going to do anything to the carboxylic acid, right? So you do this, then you got alcohol, you got the carboxylic acid. So you may think that you could make an ester, cyclic acid, the lactone. Why would one should think that? Because if that happens, you're going to make a 5-member ring, just like it's shown there. It looks pretty similar, right? This looks very similar, except this is an OH, that's a carbonyl. This is a lactone, that's a cyclic ester. This is not a lactone, that's an acetal. You can see here how similar looking they are. So you gotta find out exactly what you need to make it in order to figure out this is not the way to go. I mean, obviously, once you make that, some of you make that, oh, I'll just reduce that for the meal. Oh, that's not that easy. immediately. So that is not the way to go. So, how are you going to do it? That's the question. I mean, the acetal form may be confusing to you, so I'll be opening up for you. In order to make an acetal, you need to have that part is an aldehyde part. That's an aldehyde here. And this part is an alcohol. If you have a alcohol and aldehyde, then this makes an attack there that goes up, right? And then that makes an acetal. So that is what we need to make it from this. If you think that, yes, that for vinyl should be reduced from the alcohol. Now, not only that, we need to convert the carboxylic acid. Now, so both need to be reduced. So some of you think that, oh, sure, then I'll be maybe treating, this is the process showing that how to form an aldehyde. As I mentioned that this hydrogen makes an attack, that goes up, that becomes an OH, that one. So this is an acetone. So, as I said, one may think that, yeah, I'll treat the sodium borohydride to reduce this, but you know the sodium borohydride will reduce that if one reduces this. So sodium borohydride is not the solution. Then next one, lithium aluminum hydride. Right? If you treat the lithium aluminum hydride, and what you're going to get is you can reduce that one, you can reduce this one too. But the issue is, this one is going to be reduced the same that what we want. But this part is going to be reduced to the primary alcohol. I mean, even though you could do this, and then you could realize, oh, I'll just oxidize that. If you oxidize this one, for instance, I mean, oops, sorry. If you think that I'll just oxidize this to an aldehyde with the PCC, then you can oxidize this one to this, but that's oxidized back to the carbonyl. So then you're not going to get this. You're going to get the ketone and aldehyde. So you have a dilemma there. Not single reagent can do what you want to do. So one other way, if this situation arises, we'll be talking about protecting a functional group, right? So we'll be talking about using like an acetal. If you have a cyclic acetal forms with this one, then you can make an acetal. Then you can reduce that with the lithium aluminum hydride. That will be primary alcohol. That will be oxidized by the PCC without touching this part. And then you hydrolyze this the cyclic acetal to a ketone, and you can have these forms. But you realize that, yes, that part is an aldehyde, but this part is not this either. So that is a problem. I mean, if you think that, oh, I'll just reduce that with the sodium borohydride, then obviously, while you're reducing this one, you're reducing that one as well. So it basically, it all comes together, goes together. And that's the problem. So it needs a very, very special, strategies to make it happen. I'm just pointing out that how easily you can go to the wrong products, wrong intermediates. So then, there's no way to make this happen? No, yes, there's a way to make this happen. It's just not this way I've been describing, because each of these processes I'm talking about have an issue. We only need to reduce this one to the primary alcohol and secondary alcohol. That only reduces the aldehyde. So that is what we need. But none of the things we discussed make that happen. Then how are we going to do it? We can guess from here. That if you oxidize with the PCC, which I will talk about, already not the right answer. This is not this. But what we can do, this is an aldehyde, that's a ketone. That's the word you should take again. Aldehyde is more reactive one. If you make an acetal here, aldehyde is going to make an acetal first, like the ketones. Then you can reduce that with a soluble hydride with an alcohol. And then you release this acetal to the aldehyde just by the water, acidic water. So it can be done. You just have to think very carefully, how you're going to get it done. Then once you have these forms, all you need to do is just a little bit of acid at it, and you will just make it by yourself. It's very right manipulation is needed. Sometimes there are other parts can be touched by the reagents or not be reacted enough. But they can, all these functional groups are going to be reacted together. So you really need a good strategy to make this happen. So I just want to illustrate that you got to choose the reagent strategy carefully. That's the one. As there's another way. If you remember, some of the reactions that is actually provide much simpler solutions. The other way is, this is a carboxylic acid. You can easily make an aspirin, right? Remember that aspirin can be used to convert to the aldehyde. What is a reagent? It's an eyeball, something that you probably don't see every day. But that reagent is a Berkey. It delivers the one hydride and then make an aldehyde, and the reagent stops it. Dieballs at low temperatures. Dieballs also reducing this as well. So you'll get both parts reduced, but not like a lithium hydride reducing these to the primary alcohol. Dieball only reduce that to the aldehyde. So this is a part. So once you make this diol reducing that to the aldehyde, this to the alcohol, then basically what happened was the same process. This attack this carbonyl of the aldehyde and make that acetal, acetal. I know this is kind of a long way to go. So if you know that ester can be used to make an aldehyde using diol, it will simplify the process. So sometimes those reactions, if you remember it, it could be very useful. But even though you forgot about all these things, there is still a way to go. It's going to be taking a long while, but it's reasonable. I'll take both answers.